So most of the job of doing 3D printing is actually getting the job. So here's Yoda from Star Trek. So, ooh, I've maybe divided the room. Okay, so what we actually need is, the first step is not having the printer. I mean, that's a nice step, but the first step is we need to tell it what to print. And we are nowhere near the stage where we can say, printer, print Yoda. Okay, so we need the 3D surface. We need the topology. We want the shape that we want to get out of the printer. And if you actually look at what the file that we tend to use is a stereolithography file, STL, because it's used for stereolithography printing. Basically, we divide the surface into triangles. And yeah, here we go. So this is a cross-section of a brain. And basically, if you see what this is printing here, it's taken Yoda's face and separated it into layers. You can just see it's kind of the striations from every layer like that. And what you end up with is instructions to fill in the gaps. So if you saw when you were printing or trying to print your shapes, some of the shapes, if you had something that was floating in the air, you could maybe put something underneath it. Or maybe because you were doing it on the flat surface, you could, so say, let's find an example. So like this piece here, you have something like hanging in midair there. So probably when you were trying to recreate the shape, you started here and moved down. Yeah? But actually, a printer has to start from the bottom or from the top for one direction. So if you tried to print there, it would just fall and the plastic would just droop and not actually go in the right place. So you have to fill in the surface. So if you can see what we're passing around there is an example of a brain that Daniil deliberately stopped halfway through the printing for this demonstration. Yep, believable. And so the idea is you can see inside it's filled with this honeycomb structure. And what that's doing is basically providing the support for the shape and allowing for imagine the idea is it's going to finish the top of the brain like this. And the idea is that when it gets to the top, if you were printing this stuff right at the very top, it would just fall and not create the shape that you want. So you need to create the support structure. And so we use this file, and actually we're going to swap over to my laptop.
Yeah. Yeah?
Yeah.
What do you want to do?
Explain what I was saying. What I just said.
All right. I don't know what so that's what actually print, that the one I gave, the brain print, actually it's one of my colleague. He had an MRI scan. And after that, he, when he created for imaging, I said, why don't we print your brain? Can I do what with my brain? Oh, sorry, I'll just create a model. So that's what I did. I created the model, the actual model of the brain of my friend. So.
So you can see here, this is example. This is something I printed before. This is a hand. And this is the instructions here. So this is the software that we use for this kind of printer to convert the instructions, like the shape into instructions. And you can see if I change how we view this to layers and we zoom in, you can see that we have the structure here, and I just moved the model, so it has to reslice that, sorry. But basically what it's doing is it's taking this model and turning it into instructions of how we want to move, where we want the print head to go by layer. It's nearly finished. There we go. Yeah, there we go. Okay. So these blue lines here, can you see these blue lines? That's the print head moving. So like here, when it's printing the ear, what we're basically telling it is to move here at this position at this speed, move here at this position at this speed, and extrude some plastic. And we can see that how it builds the model up. So we can turn some of the layers off. So this is how it will build the hand. Like this. You can see basically what it's doing is it's going around the edges of the bone, but I haven't told it to print solid. Instead, what I'm doing is I'm printing this honeycomb structure inside, and that's basically giving it the support as it prints without having to print a solid model. And we can go live via satellite right now. Yeah, there we go. So this is my printer in the office, which is currently printing this hand right now. So this is printing the hand right now. So it's a bit slow because it's going through a Raspberry Pi, through a remote desktop, through the pub's Wi-Fi, and now it's very busy, so the Wi-Fi is a bit slow. But so this is printing the hand right now, and we can go to the G-code viewer, which is the G-code of the instructions, and you can see that this is what each individual layer is printing. So now it's doing an outline of the hand, and it's moved up to the next layer, and it's slowly filling in the space. And what we end up with is basically something like this. So what we want is the software to convert your Yoda model, your hand model, your brain, your friend's brain. You basically, what you want to end up is something like this, which is basically saying, go at this speed to position X, Y, and Z, and extrude some plastic. And then whilst you're extruding plastic, please move to position X, Y, and Z. And it sends that hundreds of thousands of millions of times. And basically, you keep moving that over and over and over again, and then you end up with the model. So this has been printing for, let me see. Yeah, printed for 4 hours. So in 3 hours, it will be finished, and we'll have a whole hand, another one of these, which may or may not be one of the prizes. It will be one of the prizes. So what's next? So swap over. Yeah, we need to swap over the laptop, sorry.
Yeah. Right. Good. 5 minutes? Okay. Right.
Is it me? Do you want to talk about this? What? Okay.
Okay, good. Then we could talk on
Yep.
bioengineering.
Okay, so I'm going to talk about biomedical aspects of 3D printing, which is more the kind of thing I've been doing in my actual real work when I'm not printing robots that draw all the time. 5 minutes, yeah, okay. So basically, we need to extract, you've all seen CT, MRIs and that kind of stuff. We need to convert that model, and Daniil will talk about this later, into 3D. But basically what we end up with in the computer is we convert these 2D planes, and we end up with something that's basically like a glorified Minecraft model that's just voxels of all the information. So that pick out the bone, in this case in a neonate. Move on to the next one. So here, basically, what we want to do is classify. You take this MRI, and what you want to do is be able to say, I want just the grey matter, or the white matter, or the CSF. And you end up with a model of every single layer and all of the pieces. So now we have our 3D geometry of all of the surfaces. So I've just said something which is so complicated that there are several buildings in London full of people that do nothing but that slide. Okay? So that's a very gross estimation of how complicated that is. And the point here is, it's not as simple as that slide. Often, this is an example of trying to segment a foot. So this is just trying to take out the bones in a foot, and you can see that how messy that model is that you get. So imagine if someone gave you the outline of that to do out of Lego. It's not going to happen, right? You're just going to get, it's just basically, if you told that software to print that, your laptop will just explode and it will cry, and then maybe even uninstall itself. So it's far from ready. So Daniil and me have got more of a kind of traditional engineering background, or anyone that works in video games and stuff like that. When you make meshes for this kind of geometry, you tend to think it looks like this, very regularly. Can you see like the wireframe mesh, like the black lines? It's all nice and regular. It's based on parameters. It's perfect. You can rearrange things. Maybe that might be too high resolution for a video game, but basically that's the kind of thing that you want to print. But what you get this is a good segmentation, and you can see basically this is what my dad would say is a muddle. It's a complete mess, and it requires a lot of refinement. So, and unfortunately, despite those people in the buildings working on it, it's often a manual process. So the real work is getting that
thing where you can have a joint, a mechanical joint, where some part, for example, if a metal part fit together, then it kind of friction so hard and it's not going to work. You can put on that joint some rubber piece or kind of soft material and print at the same time, so it naturally will bond together. Also, I did the whole experiment for my research, where I experimented on understanding the acoustic properties of the 3D printed material using the setup that's been 3D printed. Quite a bit. So I had a particular holder that I designed myself and 3D printed different block of materials, and I investigated a bit of data. this one was the most important bit. What I ended that some material, a lot of different materials I investigated. Some materials they're more hard, and the speed of sound, that's one parameter, and another parameter is attenuation. That meaning that if you shout at the block of 3D printed and how well you can hear on another end of that block. That's basically what I tried to work out. And yeah, exactly. Scream. Of course, you use the equipment. That same. If you would be able to put another person. If I print the block between us and I shout it and he can hear it and tell me, describe me how well it is, that's exactly what the experiment I've done. And I found that 3D printed materials in general are not very good. It was kind of, at the same time, it's a challenge. At the same time, as a scientist, you always think, if there is a challenge, that means there is the opportunity to do something about it. And I'll tell you more about that, what I did after I've got this result. I've come up with some few ideas and eventually raised about £400,000 to develop my research and around that area. So I will talk a bit more about that.
Thank you for joining us for this video of 3DMedNet at the Pint of Science Festival in May 2018. You can watch other videos from this series via the website at www.3dmednet.com or join the conversation via Facebook, Twitter and LinkedIn.